All right, I'm going to go a little out of order on things today for a couple reasons. One, it's always fun to mix things up. I want you to watch this video real quick. Remember I told you braking distance has to do with parabolas? Yes. Okay. So we're going to have, I want you to see this application. So we're going to talk about the Formula One car. And as you sit there and go, well, what the heck is a Formula One car? Well, let's take a look at it. All right, so 1, 4, 3, 2, 1. So we're out here. Okay, pretty fast? Yeah. It's under the Lincoln Tunnel, which goes between New York and New Jersey under the Hudson River. Okay? So, Formula One car, it's a race car, right? Fast car, they learn how to turn left a lot, and we're like, wait, that's NASCAR. So they say here that an average F1 car can decelerate, so it has a negative acceleration, from 100 kilometers per hour, which is 62 miles per hour. Let's put that up on the board. 62 miles per hour to 0 miles per hour, meaning they're stopped, right? Let's see, and I got that information in about 15 meters, which is 48 feet. Okay, so to put into perspective, 48 feet. This room is probably about 25 feet, so 2 of these rooms in length. Good stopping distance? I mean, 62 miles an hour, 48 feet. Wow, that's quick. All right, so let's talk about what this means. We have the information, we have the knowledge of how to do this. Does everyone understand where we are at with this? Where we're going with this? Does this make sense? Yeah. So let's utilize it. So 62 miles per hour. Oops. 48 feet. So basically, that is a parabola. So at 0 miles per hour, it would stop in how many feet? 0, right? Okay, so if we wanted to create a graph of it, we would have 0, 0, and we could label this miles per hour, and this feet, and this represents braking distance, okay? And at 62 miles per hour, so let's say we went 10, 20, 30, 40, 50, 60, and 48 feet. So 10, 20, 30, 40, 50, 60. So this other side's dotted because you're not going to do negative miles per hour. Great. But we have one side of the parabola that is useful information for us. So what's our vertex in reference to? 0, 0. So 0 miles per hour gets us 0 feet as a braking distance. And at 62 miles an hour, it takes 48 feet to stop. Okay? Well, let's use our equation. Y equals A x minus h, quantity squared, plus k. Help me label. What's h? What's k? They are x and y, but h and k are the vertex. What's my vertex? 0, 0. So h is here, k is here. Which one's x, which one's y on the other one? 62 and 48. Okay? So John, what we're doing, we just watched a video of a Formula 1 car going through the Lincoln Tunnel at about 180 miles an hour. Okay. So it's on video, so you can watch the video later and catch up. But we discovered that 0 miles per hour, 0 feet is the braking distance. 62 miles per hour, the car can stop at 48 feet, which is just a little bit longer than, or a little shorter than 2 of these rooms. Okay, so let's plug things in. Y is 48. A, do we know? No. No. Do I know X? 62. Do I know K, or H, excuse me? 0. Do we know K? Cool. If you have a calculator, can you get it out? Because I need help on this. I can't do it with my head. Okay, so I know that this is going to be 48. And then this is going to be 62 squared. So I need 62 squared, please. 3, what? 3,844. Okay. And then plus 0, so we don't need that. So that was 62 squared. So then I'm going to divide each side by 3844. What is 48 divided by 3844? It should be a decimal.
0.012.
0.0 what? 124. Do I have that right? Okay, well, I think we're good. That's pretty good. All right, does this seem okay so far? So our equation with this Formula 1 car is y is equal to 0.0124 x minus h, which is 0, squared, plus k, which is 0. So my equation could be this. Sense? All right, now let me ask you this. Let's see if we can figure this out. X represents what on our graph?
Feet. Or no.
Miles per hour. So X is miles per hour. What is Y? Feet. So it's our braking distance in feet. Okay? So we know this. We know that this Formula 1 car can stop when it's doing 62 miles per hour. It can stop in 48 feet. We know that at 0 miles per hour, it takes 0 feet to stop. Duh, that's obvious, but that's our vertex. Okay? We don't have to use the left side of our parabola because we're not doing negative miles per hour. Now, some people might argue, what if you're going backwards? You're right, but you're still going a certain mile per hour, so you're not necessarily going backwards. great movie, by the way. All right, so let's think about this a little bit further. So here's our equation. Y equals 0.0124x squared. Okay? So if I interpolate, that means that I'm going to put something inside of our data. That means that from 0 to 62 miles per hour, I'm interpolating. If I go outside of 62 miles per hour, I am doing something called extrapolating. Okay? Extrapolating outside the data, interpolating inside the data. Does that make sense? So well, let's have some fun. Let's extrapolate. Okay, I know that these Formula One cars can go up to 200 miles per hour. Make sense? That's fast, right? Now, usually Formula One cars will top out anywhere from 225 to 230 miles per hour. That's pretty fast as well. If you're doing 230 miles per hour, a football field is done. Okay? If you ever get the opportunity to go to a race, I mean, when you watch on TV, it doesn't give the same perspective. But if you're sitting in the grandstand, it's like, I mean, they just fly by. They go by so fast that your eye cannot see clearly. I mean, you see the car going, oh, there it goes, but it's like, it's gone. It moves fast. So let's figure this out. So let's say we know that the top speed of our car is 230 miles per hour. That is fast. Yes. I mean, you're moving. I think it'd be kind of fun to go that fast. I don't know if you could actually pull it on, I-25, but hey. So what might be useful to somebody would be to figure out what the braking distance would be if I was doing the top speed of my car. Okay? Of my Formula One car?
Oh, yeah.
Because I have a race car. Pretend. Just pretend. Well, I'm just pretending. Yeah. In my dreams, sometimes there might be a Formula One car that I get to drive. I think it'd be cool. You got that right.
But he can't do that math problem.
So if I plug this in at 230 comma blank, this blank, remember we said the y component represents our braking distance. So if I know that 230 miles per hour is my top speed and blank is my braking distance, what would I have to do with our formula that we now know in order to find our braking distance? What value is 230, x or y? X. What do you think I should do at 230 to figure out y, my braking distance? Plug it in. So I can plug this directly into here. Again, I need help. I don't know this. So I need to know order of operations would say do the exponent first. So what's 230 squared? It should be a big number. 52,000 something? 900? Now multiply that number, that 52,900 that you got, multiply by 0.0124, please. Multiply 52,000, whatever you came up with, times 0.0124. Say that one more time, please. 655.96 feet. Okay, so let's put this in perspective. 655.96 feet. A football field, if you go from the back of the end zone to the back of the end zone, so you're including the touchdown areas, right, is 120 yards. 120 yards times 3, that's 360 feet. 360 feet doubled is 720. So this braking distance, 230 miles per hour that you're doing, it takes less than the length of 2 football fields to stop. Okay? Is it quick enough to stop you? I don't know. Hopefully that accident is happening at 656 feet away, and you would stop and still have 0.04 of a foot to contend with. Huh. So what are some other things we can do? So we know at 230 miles per hour this could take place because we extrapolated it, meaning it was outside of our data.
Well, I mean, even if you crash out of a car like that, if you have the material that you're supposed to use, you can literally crash one of those cars at 200 miles per hour, and your body will literally just keep going until you harm it. It's the equivalent of armor.
No, I understand. I'm just saying that the car itself
Yeah,
is.
those cars are expensive, so you know.
Yeah. But if you're already, that's what you're
Well, one thing I have one thing I have learned about race cars is if you're able to stop and not crash, you should be able to finish the race. If you crash and total your car, you're out of the race. So that's pretty good breakage. Now, here I have a question for you. So let's say you got this car out there cruising, and he hits his brakes as hard as he can. And let's say this person hits their brakes as hard as they can, and again, we're still using this formula. Okay? Let's say they hit their brakes as hard as they can, and you notice that the braking distance is 255 feet. Okay? So you notice, like you were sitting there out there going, here comes the car, vroom, vroom, vroom. They hit their brakes and get to a stop, and you find their initial brake hit point because it's a little skid mark before the ABS kicks in. So you find that, and you go and you measure with this little thing, this little wheel. It says, oh, okay. It went 255 feet before it stopped. Okay? So this is a braking distance. Which component of my formula up there is a braking distance? Y. Okay? So now I can take 255 and plug it into Y. Okay? So now we have to sort of undo this. So our first step in here is I should divide each side by this. Still with me?
Yes.
Can someone help me out? I don't know what this is. So that means that x squared is equal to that. 255 divided by 0.0124. God bless you. What do you think? 2056.45. It is. You're absolutely correct. So that's what x squared is equal to. How do I know what x is equal to then? No, not divide.
Square root.
Square root it. Square root each side. Because in order to do this, if I go this and this, so what is the square root of 2056.45? How much? 45.34?
Yes.
45.34?
Yes.
X. And that's x. And x, we know by our equation, is miles per hour or feet? So here comes car, hits his brakes real hard. You're like, oh my gosh, I wonder how fast he was going. And then you go and you measure it. So, Tristan, you nailed it. You said, shouldn't the number be so much smaller? You're absolutely right. Because we had the squared value, and a squared value should be bigger than a not squared value.
Yes.
So what seems like an unbelievable distance, 255 feet, which is way shorter than a football field because the football field is in yards. Okay, end zone to end zone, if I went from the 0-yard line to the 0-yard line, is 300 feet. So this car at 45 miles an hour stops in that distance. So remember I had told you that if you go get in a car accident, it's always somebody else's fault.
Oh, yeah, I remember.
You're doing 80 miles an hour through a neighborhood. It wasn't my fault the kid jumped out in front of me. You're doing 80 miles an hour, you moron. Okay? So when the cop says, "Well, how fast were you going?" I mean, the kid just flew 900 feet because your car hit them, and then all the energy of your car went to the kid.
Like a football.
My head's so long.
Yeah, I'm going kind of morbid. I'm sorry. But here's the thing: you're going that fast through your neighborhood. The police are going to figure out your initial braking distance. They're going to measure it out, and the police officer goes, "Well, how fast were you going?" I was going like 10.
But what if you don't brake?
If you don't brake, well, then you're going to have to figure out the inertia of that kid, which is also possible. Okay?
Or you can just slow down very slowly beside them, like right next to them. I was doing like 10.
So here's the thing. My wife thinks this is funny with me. She's like, "You're such a hypocrite." Okay, when I'm on the highway, I go above the speed limit. I really do.
Rebel.
I know. I have no problem doing that.
By how much?
I don't know. Sometimes way too fast and sometimes not fast enough. Depending if you're driving across Texas or not. You know Texas. If you're not doing 100 miles an hour on I-10, they're going to run you off the road. And my wife's like, "Don't slow down. It says 85, should do 75. They're going to shoot us. Seriously, Texas doesn't tolerate you doing under the speed limit.
Where's Route 66?
Huh?
Where's Route 66?
Hey.
Isn't that like one long?
Yeah, it's one of the original highways of America. It used to go through small town USA. It goes through like Kansas, and part of Colorado, some of Arizona, into LA, all the way from, I think, New York. But it's not utilized as much as it had been because it's not a freeway, it's a highway. And highways have a lesser speed limit because it's usually 2 lanes. Sometimes it'll go out, front and back when you're going across, whereas the highway's always split and higher speed. So it's not preferred by people to go on Route 66 any longer because it takes you longer to get to a location because you're not able to go
They should raise the
75, 85 miles an hour. I mean, I've seen like Route 66. There's parts of it that will get you up to a whopping 65 miles per hour.
Oh,
But
walking.
will cops actually like stop you if you go over like the speed limit?
Those small towns, they love to have that cop posted right before the town. They have no problem taking your money. Yeah, here's a $3,000 ticket. Are you kidding me?
That's like the best part of their day.
Yeah, they're like, "Hey, welcome to our town. And by the way, here's a list of our restaurants in town. Have a nice day." So,
Please come to the courthouse in less than 3 days. Enjoy our restaurants and.
generally, it's just go pay the ticket. You pay the ticket by mail and call it good. It's not worth fighting. So,
I will fight that 5 miles to take my last.
there you go. So, long and the short of it is, this is an application of math. This is an application. So, I will be going through the homework here in a few minutes, but I want to get this out to you all. And this is exactly what we were just doing. Okay, so some applications of parabolas, but I thought watching a video of a Formula 1 car going real fast was kind of cool. Yeah. What's that? We're not to exponentials yet. Tell your tutor. You're ready? All right. All right.
Wait, you ain't got it set up.
All right. Let's talk about this. Here we go. So solving quadratic equations. We have just got to this. Okay? The equation y equals a times the quantity x minus h quantity squared plus k is a great formula for to use because a lot of times you will be given the vertex and you will be given another point. Okay? So, first problem down here says the entrance to a retail store is a parabolic archway. Oh, this isn't quite as fun as the formula car, but some people might like architecture more. The height in feet of the archway is modeled by the equation h at t is equal to 12x minus x squared. So does this parabola open up or down? Down. How do you know? What's negative? Which part of x? Which x? X squared is negative. Okay, so it's kind of out of order. So the entrance to a retail store is represented by this. So we have x. Oops, let's get back to this. We have x, and we have h at t. Okay, which is the same thing as y, but we're representing height. Okay, so this parabola, how high is the archway at its peak? Well, I don't know. Let's try and utilize this equation. If I have 12x minus x squared, let me rearrange the order of this. That's what h at t is equal to, which is y. So let's change the order a little bit. So I can make it negative x squared plus 12x, and then I'm going to have my c value be 0. Is that okay? I don't know it. Do I have enough information to solve, let's see, the vertex? Can I find the vertex? Any ideas? What's the quick equation we got? Negative b over
2a.
negative 2a. So negative b over 2a. Negative b over 2a. And then plug it in. And we should be able to find the top of this building. Okay, my a value is what? Negative 1. My b value is? And my c value, no, not negative 12, is 0 because it's unknown. Plug in, yes. Plug in. All right, so negative b over 2a. So I have negative 12 over negative 2. Good. So what does that reduce to? 6. Good. Okay, so if I plug 6 back into my equation, I should be able to find the y component of my vertex. So negative 6 squared. Well, 6 squared is 36, and I bring the negative along for the ride. Right? Negative 36 plus 12 times 6. 12 times 6 is 72, I believe. So at negative 36 plus 72, that's 36. Okay. So my height. What's my highest height? 36 feet. Awesome. So at 36, so let's count by 2s. 2, 4, 6, and there's a 0 here, obviously. 8, 10, 12, 14, 16, 18. Okay? And then 36 feet is my highest, so perhaps we could count by, I don't know, 5s. So that's 0, 5, 10, 15, 20, 25, 30, 35, 40, 45, I guess I could go up to. So we know at 6, 36, so 6, and then 36, just a smidge above it, right? So let's just label that 6, 36. This parabola opens up or down? Parabola opens up or down? Down, because our x squared value is negative. All right? So some other things we should know. If I have 12x minus x squared, and I want to know where it crosses the x-axis, I can set it equal to 0. I can have my y component be equal to 0, and we can solve that. So let's take a look at that. Is there a greatest common factor in there? Remember, greatest common factors are numbers or letters. Someone said it, there's an x in common. So 0 is equal to, factor an x out, 12 minus x. Still with me? So then I'm going to take each of these components and set it equal to 0. So I get x equals 0. And then I get 12 minus x equals 0. So that's negative x equals negative 12. So x equals what? 12. Good. So at 0, 0, because it's crossing, remember that 0 is my y component. And at 12, 0, those are my two components. So I have here, and I have here. Yes, this keeps going. Goes like that. So that's basically my archway. So x is in, let's see, the height in feet of the archway is modeled by this equation. The entrance to reach also is a parabolic archway. How high is the archway at its peak? So it's 36 feet tall at its peak. That's represented by the vertex. What does the 6 represent, though? What does from here to here represent as far as our archway? Yeah, it's the distance. This is how wide it is. So my archway at the very, very bottom of it is 12 feet wide. Okay? Halfway in the middle of it is the highest point of my archway. Hopefully that's how an archway would be created, because it would be more alluring to your eye to see. If you had an archway that was off-center, it'd be kind of like going, did you try and squeeze that in there and it didn't work? Uh-huh, I thought so. Okay? Sketch the graph of the archway and label the axis. We have that. Okay, that's B. How wide is the archway at the base? Okay, can we answer that? 12. It's 12 feet wide at the very bottom. It gets closer as you get to the top, but that's how it is. Will a box that is 8 feet wide, will a box that is 8 feet wide and 22 feet tall fit through the archway?
Yes.
You say this. Okay, will something that is 8 feet wide, so 8 feet wide is basically from here to here if you were centered, right? Is that 8 feet from 2 to 10 feet?
Yes.
Okay? So what we have to figure out is this region here, is this tall enough? It looks like on our picture it could be 22 feet. So our picture might be off a smidge. Okay? Now, do you agree that this is as centered as I could get with my box?
Yes.
I mean, if I go this way, it's not centered. This is as far as I can go with my box. And I know here, height-wise, it's 36 feet tall. So at 2 feet or at 10 feet, because of a symmetric value of our parabola, bless you, symmetric value of our parabola, those should be the same y component. So how can I utilize my equation that I know here to determine if this truly will fit? Yeah?
Why can't you just lay it down so it's 22 feet long?
Maybe it's one of those that says, hey, stay upright. Maybe it's full of, lobsters or something you want crawling over the floor.
I would want lobsters.
I like lobsters, especially after you put them in a boiling pot for a while with
They
some butter.
scream when you do that.
I know, but it's
Spiders scream if you hold them over the fire.
Gage, I know that.
Yeah.
Because I used to kill black widows and you use WD-40 and a lighter,
Yeah.
and you'd hear it go.
But if you put them in like a fire, like a frying pan, and you hold them over the fire, they'll scream.
Yeah, buddy. All right. All right. So, does this box fit through our archway? Some of you are saying yes, some of you are saying no, some of you are like, I don't really care. You care if you own this restaurant. Shh. So, how should I verify if this will fit? At 2 feet and at 10 feet into our archway, we will have the same y component. What should I do with the 2 and the 10 or the 10 to verify how tall it is? The 2 and the 10 are both x values. Do you agree? Yeah. How do I find my height value? Help me out. Wait, go ahead. Yeah, there you go. So you can plug it in here and here. Okay? So you have 12x minus x squared. And at 2 feet and 10 feet, it's going to be the exact same thing because it's a parabola. So let's plug either the 2 or the 10 in. It's not that big of a deal. So let's plug the 2 in. So I get 12 times 2, which is 24, minus 2 squared. 2 squared is 4. How tall is the archway?
36.
24 minus 4? So the height right here is at 20 feet. That 20 is here as well. Is this box fitting in there?
No.
Not unless we start cutting up that archway a little bit.
Yes.
Vandalism, bring out the chainsaw. Okay? Okay, so could this be a practical application? Could there be a scenario where a piece of furniture that can't be turned on its different side or maybe it's way longer. I mean, have you ever gone out furniture shopping? Nope. I don't recommend it, but at some point in your life, you'll probably go and find some furniture. And I will tell you one thing. If you go into the store and you're looking at some big old sectional couch, when you're looking at that sectional couch in the store, your verbiage is, yeah, that'll fit my room. And then you better measure it. Because I'll tell you what, if you're sitting there looking at that sectional going, oh, that's a nice sectional, I like that. That looked good. That looked good right there in front of that TV. Oh, yeah, we got enough room. And then you go measure a room, and then you measure the couch, and you're like, wait a minute. That is so not going to fit my room.
But if it's a sectional couch, then
Take the sections out.
rearrange it.
I understand. But not all of them will always fit. I mean, some of those couches that are out there, and I think you all can agree with this, some couches that are out there are pretty darn big. Now, there's some that are smaller. I get it. But we just got done remodeling our family room, and we went out, and I felt we have a big family room, and I got stuck in the same problem. And, you know, I'm that guy who bring tape measuring because I should look like I'm a utility worker. Bring tape. Let's measure this. Oh, it's 38 feet. Oh, wait a minute. My room isn't that big. I'm just throwing an arbitrary value out there, but just realize there's a lot of times that things will should fit, but they won't. And this is a perfect example. This could be a real-life application of sometime in life. Now, some of you say, oh, I'll never have an archway in my house. God bless you for not. Okay, but let's say you don't have a choice. Okay, I understand. The area of a rectangular garden. Rectangular garden. I know, I love to garden. I'm a gardener. I love my tomatoes, and I love I grow string beans, apples. My apple trees are full of flowers. I can't wait because we make applesauce and we make apple pie filling. Oh my goodness, it's unbelievable. We do cucumbers, so we pickle them. We do zucchini, which zucchini. I just throw it on the grill. I'm not a big fan of zucchini. But if I grill it with the right spices, I'll eat it. But I love gardening. All right, so the area of a rectangular garden is represented by 2x by 6 minus x. So this is basically, this is a length, this is a width. Still with me on this property? Okay, and we don't know, for whatever reason, we don't know all the fundamentals. We just know that the length of it happens to be twice the width, and the width is 6 minus x, okay? So use a calculator to find the maximum area of the rectangle. We're not going to worry about that. Well, let's figure this out. Let's see. Oh, hey, you know what? This is already set up for us to figure out where it crosses the x-axis. Why do I say that? We already figured this out, where it crosses the x-axis. How can I say that? Why? Because why? So watch this. If I wanted to figure out where it crosses the x-axis, which is basically here, where our y component is 0. Watch this. 0 is equal to 2x, and 0 is equal to 6 minus x. Bless you. So x equals 0 here. Okay. What's x equal to here? 6. If I subtract 6, I get negative 6x, or negative 6. Negative 6 equals negative x equals 6. 1, 2, 3, 4, 5, 6. What's halfway between those? 3. Tree? 1, 2, tree? How do I find my vertex? Vertex happens halfway in between because it's symmetric, yes?
Yes.
How do I find my vertex from there? That is my axis of symmetry. We know that. Do what? Any other suggestions? I love the axis of symmetry. We've already made our way into the center. I like that. That's 3. How do I get my...
Solve for it and plug in
the x or y? X. Good. So if I plug 3 in for x, I get 6 And then if I plug 3 in for x, I get 6 minus 3, which is 3.
We're good at this.
Yeah, so at 3 comma 18 is my vertex. And I realize I kind of made my thing, kind of
I
squatty.
don't think that's to scale, sir.
Let's just pretend. We have it labeled. We're counting by 18s on the y-axis.
Okay.
Sound good? So at 3 comma 18, so 3 comma 18, 3 comma 18, 3 comma 18. So let's see, my x component, which is a certain length, and my y component, which is actually an area. So my y component is an area, my x component is a length of some sort. So if the unit of measure for the rectangle is in feet, find the perimeter of the rectangle that maximizes the area. Well, the vertex is going to maximize. Yeah, draw a diagram, interpret the vertex of the parabola. Okay. So let's interpret this. So if we have a length of 6 and a width of 3, we will have a maximum area of our garden of 18 square feet. Where did I just get the 6 and the 3 from? Yes. What value is this? X. If I take my x and plug it in, 2 times 3, we call 2x length. 2 times 3 is 6. At 6, we have a maximum length. At 3, we have a maximum width. We have a maximum area because 3 times 6 is 18. Our vertex is 18. So our maximum that this can happen with is we have 18 square feet. If the unit of measure for the rectangle is feet, find the perimeter of the rectangle. So I have 3 by 6. So I have a 3 by 6 rectangle. So I know that's 3 and that's 6. What's my perimeter? What's my maximum perimeter? 6 plus 3, which is?
9.
6 plus 3, which is? 9 plus 9, which is?
18.
I am at, so 18 feet will be my perimeter in this scenario. That will give us a maximum area of our garden. Calculate the roots of the function, relate them to the diagram, and interpret the meaning of the roots. Well, our roots is here and here. Our roots aren't dealing with the garden of our vegetables. So if I have an x value being 0, if I have a length of 0, wait, I'm not going to have a length of 0. So that's a silly answer. But if I have a component of 6, this is going to work out for us. And the 3 is the maximum value that our x value should be in order to optimize the maximum area of our garden. Okay? Now, do you really do this when you're having a garden? I doubt it. I have a region in my yard. I have a few regions in my yard in which I have some large barrels that I plant plants in. I have some rectangular gardens I plant plants in. I have a really long rectangular garden that's along my fence line that I plant carrots and radishes in. And then I have this other garden that just doesn't really have a shape to it that is of the square rectangular family. It's kind of the blob shape. It kind of goes, so the people who own the house before me decided, oh, let's make this shape. And it doesn't really grow real well in some regions, but it does grow cucumbers well in the center, so I'll take it. Sweet. What do you guys think?
I think if you have a garden better,
Garden better and move to Texas?
yeah, it doesn't have the greatest dirt, but it's good pathway for dirt, and it has really good.
Awesome.
I only know this.
Because you live there, right?
I only know this because my stepmom lives there, and she just does it.
There is nothing wrong with that. Gardening is, I truly enjoy it. It's one of my things that I enjoy in life. So, guys and girls, We didn't get all the way through. We'll get to slide 4 later. But I would like you to work on, for your homework, I want you to start on this. Worksheet number 10, which is page 119, 120. And I want you to start on this. But I want to make sure that worksheet number 9 is done. So I will check off worksheet number 9 first thing tomorrow. That was last night's homework.
Oh, right.
Sound good?
Yeah.
All right.
That sounds nice.
So I